Let's take a look at the solutions to logarithmic functions, part 1, exercise solutions. So rewrite the following exponential equations as logarithmic equations. So the first one, we have 5 raised to the third power equals 125. Remember, the base of the exponential function is the base of the logarithmic function. Logarithmic functions are equal to exponents, and you take the logarithm of the result of taking that base to that exponent. So when we write this out, the base of the exponent is the base of the logarithm. Logarithms equal the exponent, which is 3, and you take the log base 5 of the result of taking 5 to the third power. So that would be 125. 2 to the negative 5 equals 1 over 32. So remember, the base of your logarithm is going to be the base of the exponential function. The logarithm will be equal to the exponent, and you will take the log base 2 of the results of the exponential expression. So that would say log base 2 of 1 over 32 equals negative 5. Now let's go the other way. Let's write our logarithmic equations as exponential equations. So if we had log base 7 of 49 equals 2, remember the base of your logarithm is the base of the exponential expression. Logarithms equal the exponent, and you take the logarithm of the result of taking this base raised to this exponent. So 7 squared equals 49, which you can check. 7 times 7 is 49, so you did write it correctly. Log base 64 of 4 equals 1/3. The base of the logarithm is the base of the exponential function. The exponent is what the logarithm is equal to, and what you take the logarithm of is the results. So 64 to the 1/3 power equals 4. Remember, raising to the 1/3 power is the same thing as cube rooting, and the cube root of 64 is 4. All right, let's evaluate the following logarithmic expressions. Log base 5 of 625. The important thing about logarithms to remember is that logarithms are equal to an exponent. So if we call it y and we had log base 5 of 625 equals y, that means that 5 raised to the y is equal to 625. So we just have to figure out 5 times itself how many times gives us 625. Well, 5 times 5 is 25, times 5 is 125, times 5 is 625, so that's 4. So the exponent we were looking for is 4. When you are evaluating a logarithm, log base 5 of 625, you're basically saying, okay, 5 raised to what power gives me this result? This base raised to what power gives me that result? And the power we were looking for in this example was 4. If we had log of 1 over 10,000, remember that the base of the common log here, if there isn't a base written like that, it's 10. So your logarithm is equal to an exponent. So log of 1 over 10,000 equals some exponent, we'll call it y. That means the base of this logarithm, 10, raised to the y exponent will be 1 over 10,000. Notice that that 1 over 10,000 is in the denominator. The only way you can take 10 to a power and move it down below is if this exponent is negative. So we can ask ourselves, okay, 10 to what power is 1,000 or 10,000? And you'd say 4. So then 10 to what power is 1 over 10,000? And that would be negative 4. So the exponent we are looking for is negative 4. Here's a different type of one. Log base 4 of the 5th root of 256. So we could try solving this the same way we solved those last problems, but 4 raised to what power is the 5th root of 256? That wasn't as straightforward as the other ones. But what we can do is we can say, okay, well, the 5th root is really raising to the 1/5 power, so log base 4 of 256 to the 1/5 power. Now, if we could make this base match, we have an elementary property number 3, that says if the base of the logarithm and the base of the exponential function match, they would cancel each other. Well, 256 is 4 to the 4th power, so this is all equal to log base 4 of 4 to the 4th to the 1/5. Power of a power, we will multiply those exponents together. And now we have log base 4 of 4 to the 4/5. The base of the exponential and the base of the logarithm match, they will cancel by elementary property number 3. And we get that the answer is 4/5. The other thing you can do here is 4 raised to what power is 4 to the 4/5? Well, then that power must be 4/5. And that's where elementary property number 3 came from. Very similar problem here, the natural log of the square root of e. We'll start by rewriting that so it's not a radical but a rational exponent, and we have the natural log of e to the 5/2. Remember, the base of the natural log is e, the base of this exponential function is e. When the base of the logarithm and the base of the exponential function match, they cancel, and that is also elementary property 3. Log base 3.6 of 1. Log base anything of 1. Well, 3.6 to what power is 1? That power is always going to be 0, and that's elementary property number 1. So no matter what the base is, log base anything of 1 is always going to give you 0. Anything to the 0 power will always give you 1. 7 raised to the log base 7 of 12. If the base of the exponential function and the base of the logarithmic function match, they will cancel each other, and we are left with 12. That is elementary property number 4. That's it for now. See you next time.